Do we have a microphone? Yeah. So need to look at this thing as well. If there's anybody who wants to do a remote input. So where's the dongle? I just put it.
Was geht weg?
Que la gente que trabaja en el chat del Miteco.
Come.
Ay, muy bien.
Una cabra ahí. ¿Dónde es?
Miteco. Control F. Buscar cosas. Me pone hecho.
Super. Sí, esto lo he usado.
Ah, no sé.
¿Qué hago? Participante, ¿no?
No, sé.
Observer.
Bueno, participantes.
Ahora en Chrome. One. Second.
Dos, entonces.
Ya, ese sí.
Se pone que let's me doing some registration. Let me do some registration. Remember me, I haven't been aware.
Okay, so welcome to the call working group. I'm Carsten Bormann, and my co-chair will have to say his name to the microphone himself.
Jaime Jiménez.
So I still need to practice that because Jaime is our new co-chair. You might want to welcome him.
Hello, everyone.
Okay, so we have no, that's the wrong one. Yeah. So we have a Jabber scribe. Ludwig, where did you sit down? Ah, there you are. Okay, so right. And so if this guy is coming to the microphone, he is relaying something from the Jabber room, or maybe he's making his own comments. Note well and everything. Scribes, I would expect our usual.
Matthias volunteered already. Matthias volunteered.
Ari. So we are going to do it using Etherpad. So if you want to join in taking notes, that would be very nice. You know where to find it. It's on the Tools Working Group page under the link Minutes. Okay, blue sheets. Yeah, you have read this note well. So we have a pretty packed agenda for our meeting, which actually is taking place in 2 slots. Today we will be more heavy on the documents that actually are working group drafts already. So we have 2 that are in or have been completing working group last call. We are 1 that is advancing nicely, and we probably want to discuss related drafts quickly. And finally, we'll have a look at the resource directory, which we want to complete quickly as well. And on Thursday, we are having the slightly longer outlook, with the core interfaces draft, the various proposals for management, object security, SNML, PubSub, and congestion control. Any additions or changes to the agenda? So let me quickly summarize where we are. Some of you will have noticed that we have a new working group co-chair, so we now finally have reasonable milestones and everything. One milestone is done. The blockwise transfer document is in the RFC editor queue now. So it will be an RFC in 2 or 3 months. We have one document that has completed working group last call, where we are just checking whether we really have dotted all the I's and crossed all those T's. We don't have an extra agenda item for that. I'm not sure we need one. Is any one of the authors here?
Hi, Kirsten. This is Akbar. So I think, as you mentioned, we're closing the final comments on the email list. And the suggestion from the authors is that, we sort of, even if it drags out, we try to close it this week. We try to do an update next week, because otherwise there might be a delay until late August because of vacations. So if that's fine with the chairs, we can do an update for early next week.
Yeah, I think the most important thing is that we are making sure that the comments that really point out potential mistakes are taken care of. And yes, when we have done that, we can go ahead.
Okay, yes, thank you.
Okay, we will talk about links and patch and fetch. SNML currently has a pretty near milestone as well, because the overall assumption was we are done with it. I think we still have to have a few discussions about it. And the next big item here is working group adoption of the actual management over CoAP draft. We have had several meetings with discussions about that. So this is going, we are assuming this is going to go fast, but we have to have the discussion. Resource directory, the CoAP over reliable draft that we will spend most of the meeting today on. If we're lucky, we're going to get the two main management documents done this year, and we have core interfaces in the pipeline for early next year. But that requires a bit more discussion, and we will talk about that on Thursday. So that's where we are. We have a pretty large number of documents that are almost complete, and we just have to make sure we do the final steps on those. So this is what is recognized as the work of the working group. There are other documents out there where people expect they will become milestones soon. Of course, our focus should really be on finishing what we can finish quickly. But on the other hand, we don't really want to shut down that other work. So in the course of the meeting, we will talk about those other documents as well. Yeah, with that, Peter.
So we are working on the fetch and patch. Oh, sorry, working on the fetch and patch document. We hope we can conclude very quickly. There are very little issues, as you will see. The objective of the documents is the payload reduction, such that we can transport parts of a multiple or one resources. Major objective. Here you see an overview of how the fetch and the patch and the iPatch, which is the patch but not for idempotent requests, how they fit together. And you see that we have this non-idempotent patch and the idempotent iPatch. and the fetch which is idempotent and self, and how that fits into the other ones. So, what has happened since the last time, which was in Buenos Aires, there was this request for a fetch example to be added. That was a very good request because we noticed that there was no content format existing, so we have defined a non-existing content format and built an example like that, and we were inspired by the wishes of the COMI example, which wants a list of CBOR elements. So that has been added. What are we still going to do? Thanks to all the feedback we got on the mailing list, that we have a response code 4.12 for iPatch when the request which is sent to the server is not idempotent. There is an admonition which we should formulate that the fetch results are not cached like the get results. We should say a few words about the HTTP co-op mapping, because it should make clear how it fits within the HTTP co-op mapping document. Then there should be an error. What happens if you have a fetch and there are multiple requests? How is the error returned for all the individual requests? That has to be added. And there's a few words of the get in the URI that we have in question mark, and you define everything which can be done to be contrasted with what we do in the fetch where it is in the payload. These are the things we have to add. I think it will take, looking at my co-author, another 1 to 2 weeks, and then we hope that we are concluded.
Yeah, Kasper, and I think the only thing that still has a question mark on it is the first point. So a server that gets an iPatch with a payload that specifies a non-idempotent change, that might want to send back an error message, and it's not quite clear which response code we might co-opt for that, or whether we need a new response code. So I think a little bit of discussion is still needed on this point. So for instance, there's also 409 conflict, which is another response code that fits into this general area. While 412 precondition not satisfied really is about options that have indicated things like if non-match and if they're really not quite applying here. So I think we have to have this discussion about the response code that we actually want to use.
The 4.09 is more about concurrency problems and the fact if there are enough resources in the server, and that is not at all the same type of problem, I think, as we have this precondition that it should be idempotent and it is not satisfied. I'm being naive here.
Yes, except that the preconditions are really about preconditions that the resource at the server has to fulfill. And if you send a non-idempotent patch with an iPatch, this is not something about the server. This is a client error. So, yeah, I think we need to have this discussion in the next couple of days.
Michael Koster, just one more point on that. If any of those response codes are expected to return hints about what went wrong, like 409 and 412, I don't remember about those, but some response codes are expected to return a hint about what went wrong, and there may be some guidance about what to choose. If, like, for example, if 409 or if precondition failed contains a hint about the precondition, and that's something that's supposed to be specified in the request, and there isn't anything, maybe that isn't the right appropriate code.
I see. Okay.
Look at the hints.
Okay. So since I'm co-author on this document, Jaime is the chair, and the chair can probably tell us what will happen next with this document.
Yeah, just a second.
This is a surprise.
I'm sorry, we were just running over from a lunch meeting, which took longer than we thought.
So with the ETH document, I'm preparing the Shepherd write-up already. So as soon as these comments are addressed, then we just send it to Alexei and continue.
It'll be lovely. Thank you very much.
So the next document that is in working group last call at the moment is excuse me, the links JSON document. This has been around for a long time. This has been essentially unchanged for a long time. And then at some point we thought we have a few more data formats where it would be nice to have additional representations. So we throw them in as well. And the result of that was that we put this is strange. The bottom is shifting under you when you're standing there. That's very strange. So we put all this stuff into the document, but this kind of took the focus out and slowed it down. So we recently had a discussion about maybe splitting that part out again. And the discussion concluded with, yes, we should do that. So there is now a separate draft, which just carries my name because I made this draft, but this is really content from somebody else. That contains the RFC 7390 part, and the callings JSON document itself is now completely focused on the RFC 6690, the link format representation in JSON and CBOR. So this issue is resolved in the current draft, and the other one was, should there be a reference implementation? And the answer was yes, so we dug one out and attached it as Appendix A. This shows an RFC 6690 parser, which is 80% of that reference implementation, unfortunately. And the JSON CBOR output plus the inverse. So those were the two issues that were addressed before we generated the document that went to working group last call. And we are now in the middle of the working group last call, so we're not going to make any decisions or anything today. One item came up on the mailing list that I think merits a little bit of discussion, which is what about the bold claims at the start of the document that we are really doing this to be a part of the bigger JSON family and JSON LD and all that. And I think Christian had a comment. You want to quickly speak to that?
Christian Amsus here. We went back and forth over this, and I think the conclusion is that it won't fly that way. And we should just, in the objectives, add a note that, yeah, this was something to be taken into consideration. It has been taken into consideration. Those and those points are why it would be abundantly complicated and add complexity to the conversion process. So this is something that has been considered, but rejected. I think this is the way to go here.
So shall we document this in the issue or really in the document that goes to the issue?
I think that it's a valid point to be in the draft section about objectives.
Mm-hmm.
But to avoid confusion, we should note, and best there, that this was an objective, but it turned out to conflict with other objectives, and therefore no further consideration was given to it in terms of choosing the precise serialization.
Mm-hmm. That sounds good to me. Any other comments? Michael is nodding. Who in this room cares about JSON LD? Matthias, you have to raise your hand. Okay. Great. Michael.
Michael Koster, Smart Things. Yeah, we care about JSON LD, but the exercise we tried to do was, could you take a JSON links file and add a JSON LD context and turn it into a JSON LD representation? And that has probably too many gotchas in it to be able to do that. But at the same time, we want to be able to use rich link annotation that can then maybe map to terms that can be looked up in a JSON LD file as a separate external semantics. So I guess you'd call it external semantics, that we wouldn't try to represent the semantics of link format in JSON LD by mapping each link format term to a descriptive URL, but rather leave the link format the way it is, be able to add semantic annotation to it in the form of resource types, etc., that those could be looked up in an external semantic database that use JSON LD or RDF in general.
So when we are done with this exercise, would it be possible to have a mechanical rule that would turn a link format JSON document into a JSON LD document? Is it that simple?
Difficult, because there are two things. The problem of there potentially being white space in some of it because of the white space issue, and the other is that there are defaults, default relation, for example, hosts, and that wouldn't be able to be resolved through a context file.
But a mechanical transformation could fill
Or
in these.
mechanical transformation being that you had an algorithm that would
Yes.
figure a lot of this stuff out.
You could have we could have an algorithm that figures all that out, but this would make the JSON the links JSON thing look very different from the link format. It would be non-round trippable. It would be far from.
I'm not asking whether we should apply this algorithm when generating links JSON. I'm asking, if we have a links JSON file, can we have an algorithm that generates us a JSON LD file, or do we have a semantic disconnect?
We can have such an algorithm, but that algorithm would need to take into consideration every additional parameter we add to the link format, and would need to be aware of that.
Mm-hmm.
Matthias Kovac, Siemens. So to elaborate a bit more, so in the WPC Web of Things working group, we for now use JSON LD because it's quite handy to do experiments, to discuss, to see what's going on. But that doesn't mean that is the only format that we want to support or anything like that. It's for now quite handy because it's quite intuitive to work with this. There's some nice tools and so on, but we at some point this should be more concise as well to be usable for things directly. It's more the exercise to see how can we convey this and convert this information to different formats and have really multiple serializations for links, for web linking, and that we do not lose too much information while converting. So that's something to consider. So it's not even specifically about this, but more how do we preserve the information that is, for instance, provided in the beginning in core link format, and how does this end up in some RDF reasoning machine, let's say.
So it's really more an exercise about mapping RFC 6690 style information into JSON. Okay, thank you.
Carrie Lynn, this might be a new issue, but speaking about making this more a member of the JSON family, it seems to me that links JSON is closer in spirit to JSON hyperschema than it is to JSON LD. So I'll make some comments on the list about why I think that's true.
Zach Shelby Arm. So just to answer your question here, which I think all we should do right now, that was all very interesting, but I think it's all irrelevant to this document. I would agree with Christian. Close this out. No, you don't need to do that. This is only meant to convert 6690 to JSON CBOR, publish it.
Thank you. So the working group call runs for a couple more days. So you can put in additional comments, and please have a look at the document. It's pretty simple. Next, curve over reliable.
How many people have had a chance to read the draft? Not bad. I'll apologize for it coming in so late. I mean, it made it by submission date, but I'd like to get things out earlier in the future. So the existing draft and all the issues have been moved to GitHub. I encourage everyone to feel free to open up issues as they find them. Feel free to submit pull requests. Certainly love pull requests. Basically, O3 merges a number of documents. So that includes WebSockets, that includes Karsten's signaling draft, the BERT work, and of course the earlier version of CoAP over TCP and TLS. So I'm going to go through the existing issues in GitHub, try to capture the spirit of them. In some case, there's straw men, and I hope that we can have some discussion here and be able to close out some of these issues or have a sense of direction for a later discussion on the mailing list. I will be capturing the results of the minutes within the issues themselves. So the first issue has to do with application layer protocol negotiation. Just as a refresher, ALPN was something that was designed, TLS extension designed initially for HTTP2. It basically allows you to do the negotiation for the next application protocol within the TLS handshake. It also allows you to be able to multiplex negotiation. So if you're on port 443, for example, you can support a number of different protocols. So the rough consensus that was in the issue for this was to require ALPN. This is what HTTP2 does. It seemed to be like straightforward. But other people have pointed out that there's a problem with some implementations, including .NET, where there is not support yet for ALPN. And a suggestion as a mitigation was, what if we allow a well-known port reusing basically 5684 from the CoAP RFC, in this case to be a well-known port where we know it's going to be CoAP over TLS. Any thoughts? Editor makes the decision.
Gabriel Montenegro. I would note that's very similar to what happens in HTTP2 under the rubric of prior knowledge, and that has been known to be used in large, very large deployments. So it seems okay. You did mention it's over TLS, so.
Yes.
I mean, what's the worst that could happen? So
you think this is a reasonable mitigation then?
Yeah, I think it's very similar to prior knowledge in HTTP2.
Okay, thank you. Any other comments? So there's an issue with a number of different questions in it that Hannes and others were working on related to observing resources over reliable transports. And Hannes was going to take a look at the issue to see if most of the issues had been addressed. However, I noticed an issue where there wasn't a question in the current GitHub issue, and that's related to the fact that Observe allows the use of confirmable or non-confirmable notifications. And in the case where a confirmable notification is used, it's expecting an acknowledgement to come back, or it will remove the observer. Obviously, in CoAP over reliable transports, we are not using those message types. And so we need to address this in some way, either to have some type of appendix in the CoAP over reliable transport specs or some other means.
Maybe just to provide a little bit more of context here. So this is really an editorial issue in RFC 7641. It's not a technical issue, it's an editorial issue. So 7641 explains if your client goes away, you strike the interest that you have in your tables. That's essentially what that red stuff there says. And if the client goes away is phrased in COIP over UDP terms. So the client goes away in COIP over UDP means you don't get an acknowledgement. Now at the TCP side, it's actually the same thing. You don't get an acknowledgement, but in this time it's the TCP acknowledgement you stop getting. But the phrasing here isn't quite transferable to this situation. So this is kind of an editorial change in 7641 that we have to make in this document. It's slightly weird, but I think we can do that. Well, this text is slightly over-specific because it explains the details of the UDP message layer that have to go wrong. So you find out your client is no longer there. And in another message layer, of course, those details will be different. So the editorial change would be to take this a little bit back to specify it to remove detail and say, if your client goes away and you find out from the message layer, for instance, by UDP or in TCP, if your connection goes away, then you take away the client interest.
Zach Shelby Arm. Just to decode Karsten's fairly complex explanation, just put a little bit of text that says, for avoidance of doubt, when using observed with the specification, the TCP acknowledgement is sufficient for determining this. Append it doesn't matter where you put it, just.
Yeah, but I think we're going to need to address it. I don't agree
Yes.
that this is an editorial issue within the observing resources spec. I think it's fairly specific.
It's got to be here.
Now, there are some cases, there's later text because it repeats itself about 3 times where it does talk about timeouts and such. But this text is very specific. But yes, we'll just need to add something to the reliable transports to say, here's how we handle observing.
Exactly.
Okay. Hannes, did you have a chance to look at the issue? Do you? Okay, then let's look at the remaining issues on that later and just make sure that everything's been addressed. I believe everything's addressed in the current draft except for this new issue.
Right now, but we better after it's fine.
So security considerations. There's always been language in the draft about, well, it used to be a negative, must not, and now it's changed to a positive, must support 1.2 or higher, but there's never been any way of enforcing that behavior. We just said you shouldn't do this. Now we have, with the signaling draft, a new message type called abort. And with abort, we can actually now enforce the behavior. The straw man is to, in this case, return an abort and either add a new elective option, which I prefer for inadequate security, again, similar to HTTP2, or I think Karsten prefers just using the diagnostic payload. Again, any preferences or any additional thoughts on this?
Just use this mic. Yes, okay.
Hannes, so I think the inadequate security option sounds pretty good for me. So since we have the possibility, we can just provide that additional payload in this specific indication.
So, Carsten, let me try to explain the design here. Basically, we have tried to design these messages in such a way that all the information that the recipient can meaningfully act on is specified as specific options, while diagnostic information is left to the discretion of the implementation. So we have the concept of diagnostic payloads in COIP, and I think it's a very good concept because it allows a server to say as much as it reasonably can within the limits of this implementation. We don't over specify things. But whenever we actually expect the other side to implement a state machine, we actually have to specify options. Now, in this case, I'm not so sure that a client would be negotiating TLS 1.0, then get back this option and then suddenly decide to lead a better life and negotiate TLS 1.2. That doesn't sound like a very likely scenario.
Yeah. The other thing which comes to my mind is that in terms of the whole procedure, so with in case of, if we don't use TLS, then we start off the initial handshake and then we have the framing and the signaling messages that go there. But now if you have TLS, you actually start with the TLS already up front. So if you mess it up, you're not going to see the abort message probably at all, right? Or am I?
Yeah, this is for the rare case. I mean, the whole discussion is for the rare case that the TLS connection comes up, but then the application gets the information. By the way, this was only a TLS 1.0 connection, hoping that there is an API for that or something, and the application decides, no, I'm not going to do that. So in that case, the application would send back this information. But a saner implementation would be, of course, to immediately reject that at the TLS level.
Right, and specifically the API, at least in our case, you would have to specify what type of TLS version you want to establish to begin with, at least minimum. So you would probably not get to the state when we say must support 1.2, and that's what the API call already says, you are not going to see anything. So maybe as the third option is maybe we should not do anything at all.
Well,
because
if we don't get to this state, we don't have to do anything.
Yeah.
The question is, what is the proper behavior when you notice your TLS implementation has negotiated for you a TLS 1.0 connection? What do you do? And definitely sending an abort message is the right thing to do. The question is, do we need an option that makes this abort message unambiguous so a state machine can react to that? Or do we just send an abort message with some diagnostic payload that can be used for diagnosing what went wrong?
Jim Shuck. So in order to get to the point where I'm going to have successfully negotiated this TLS session, I've had 2 failures already. My client has failed and your server has failed. Well, no, if I said I need at least 1.2 and the server came back with something less than 1.2, it failed and my client failed. Because my client should have shut down right away. And if I said I want 1.0 and the server says it has to be at least 1.2, it's not going to negotiate a session either. So, I mean, you're talking about a case where both the client and the server are incorrect to get this to happen.
Matthias Kovac, I'm wondering about the use case here, where this would happen, that you have basically a setup where you have no control about the DTLS layer, and then you act suddenly as the application. So the thing I can come up with is some kind of cloud service. You're super flexible, you provide whatever your customers want, but then they have to basically implement in the application somewhere what they actually want to allow. Exactly. So if this is the case, this is very application specific at that point. So for that reason, I would also prefer this diagnostic payload, because it's something some application decided to handle. It's nothing that is really standardized down the stack, because you already loosened that. You do not define the whole stack. You provide anything at the TLS or DTLS layer, and then let the application do something specific. Is this assumption right, or are there other use cases to allow this kind of actually weird behavior, in my opinion?
No, I don't know that we have any other cases. Basically, it's being modeled the same way that HTTP2 is modeled. Mm-hmm. But if the feeling is that it would have to be an application level failure and not just poor implementations all the way down, then yes, we could go with the diagnostic payload, because that would be application specific.
Okay, thank you.
Any other comments?
Montenegro.
Everybody,
Yeah, comment on the previous thing. So I'm wondering if it could also be used, I mean, sometimes you misconfigure stuff. And in that case, it's not an application issue, it's the fact that you misconfigured. So perhaps in that case, having a very clear signal that, hey, you screwed up is easier for troubleshooting and debugging.
yeah, that's an edge case, but possible, definitely.
But that's already happening. So it's you have this clear message of you screwed up, you aborted, and then you have this freedom to say what exactly went wrong. You can even be more specific. Hey, this is a configuration issue. You don't have this flexibility unless you define many of these options to cover every kind of case that could come up. So I think what you brought up is perfectly covered. With, for instance, so I understood you want to have like a more standard way to say what exactly went wrong. So that I understood this as these options that should be defined to clearly state, okay, this is what went wrong. That's what I understood. And I would say with the diagnostic payload, you have the same thing, because the strong standardized way to say there was a failure is the abort message itself already.
This is the ever popular mandatory TLS. So I spent a little bit of time looking for what the current guidance is. I mean, between pervasive monitoring and surveillance databases, looking for unsecured IoT devices. I was curious if we were getting a bit more hardcore about guidance here. But the current guidance does seem to be like mandatory to implement, but optional to use, or prefer encryption to clear text. And obviously, the current implementation supports the spirit of that. Does anyone feel strongly about mandatory TLS and would like to speak to that?
Matthias Kovac. So mandatory TLS is something different than mandatory security. So I'm in line with the first part, so that it's mandatory to implement security, and we should have something. Maybe to be more specific, so there's this object security coming up. It's quite interesting if you also have like intermediaries in the queue, if we look or revisit this group communication pattern, for instance. So this is kind of a direction that could provide useful security and could give you or address this issue. So if we now make TLS a must, we could layer so many different security solutions that it's actually just too much, although kind of the upper layer already would have given us enough security.
Yeah, so of course this application layer security and the use of it is a little bit as a speculation, because the way how people use in a web case also use these mechanisms today is if you terminate the different connections in different places, then you still don't just use application layer security. You then use TLS underneath it, and then you have some application layer security solution that does some. If you think about some more complicated protocols like SIPs or XMPP who use multiple hops and need to also protect certain objects over the hops. The fact that you use TLS with a proxy provides different properties. So nobody's saying that just because you have some end-to-end media exchange that you don't need any other TLS security there. And that's sort of the analogon here. But how that really gets used and how even it will work and so on remains to be seen. That using multiple layers of security is more expensive is clear, but you would probably have some radio level security terminating at some completely different box, and then something higher up as well. That's a separate story.
This is actually Arm. So this is obviously in the spirit of RFC 7252. This is what we say there. We could do the same, or we could be a little bit more radical. I wouldn't go as far as saying that TLS must always be used. But I would actually suggest we set a good example and go a little bit further than this. The issue with embedded systems is that in a lot of these implemented stacks, just having an implementation of TLS is still a long way from being able to use it. So what we tend to see is that there is a TLS implementation, but configuring it and getting it to actually work takes a bunch of work. And what will happen is in OEMs that are going to create their product, that takes extra work, it's difficult, they won't use it. We've seen this over and over. So I propose that we go further and say that mandatory to implement and mandatory to have on by default. You can turn it off, but it's got to be there to start with. We do this, by the way, at ARM. We turn this on by default in everything that we have. It's hard to turn it off.
What do people think about that proposal? I saw some thumbs up.
Yes, so I'm perfectly in line with this. I mean, this is kind of how you should do it anyway, written down more explicitly. And it doesn't close the door if we find another configuration or a combination of different securities at different levels that might be turn out better at some point. So we still have the flexibility, but have this kind of strong recommendation how to do things.
Turning on TLS doesn't make things secure. So I think the important thing here is to ensure that we actually have security. And turning on TLS may be one step towards doing that. However, constrained implementation does not necessarily have everything that allows it to use TLS with the kind of security you would find, for instance, in a cloud peer. So I'm not sure that this actually does very much. But then on the other hand, it probably will be ignored anyway. So it doesn't really hurt to actually put in something that is a bit more powerful about saying, hey folks, this is meant to have some form of security. I'm not entirely against doing that, but I think it is important that we actually specify all 4 cases over TCP, over TLS, over WebSockets, and over WebSockets over TLS. Because if we don't do that, then other people will do that, and that is going to be worse.
Dave Taylor. I don't know if there's any other IAB members in the room right now, but I'm one of them whose name is on that 2014 statement. And so I was one of the people that gave a thumbs up to the statement that it should be on by default. I think that is in line with what the IAB would say when it says the word prefer down there. But
Okay.
if it's not on by default, then it's not preferred.
Thank you. So there doesn't seem to be any, I think the person who opened the issue was a little more hardcore about not supporting TCP at all. I don't feel that there's any interest in the room to go that far.
I like the on by default idea, but my concern there is if we use other mechanisms, are we able to take this TLS functionality away if it's not used in some kind of scenario? So would it be extra baggage always because it's mandatory to be there, mandatory to be on by default?
And this is Hannes. I find it interesting because you often hear in presentations like in also IETF, and I think in the Think2Think research group as well, when we complain about the lack of security in IoT and how bad everything is, and developers should really take care of these type of things. And as soon as we get to the point when we talk about like writing the specification, it's sort of like, maybe there's some other mechanism people want to use. Everything is sort of like leave it wide open. And then we are so surprised that people get it wrong. So there seems to be a little bit of split personality issue here.
Carsten Bormann, that much is true, but on the other hand, you don't address lack of security by just sprinkling your magic dust over it. So it has to be real security and not just I switch TLS, so now I switch on TLS, so now I'm secure. I think that's really the admonition that should be in there. Make sure that your security objectives are well understood and are satisfied by the security solution you're using. And if you don't have anything else, use TLS.
And I think there's no concept like is secure, is not secure in general. Like, but for this problem at hand, the challenges are communication security, the classical communication security challenges. And for that type of mechanism, TLS is the right choice. So there's not any other sort of, we're not talking about, there are many other considerations that one might think about, like where do you store the keys and so on and so on. This is not something that we would sort of discuss in these type of things, which would also fall under the wider umbrella of is this secure or not. But it's not something we generally have dealt with anyway, or is the implementation, the code implemented properly and so on. So I think nobody talks about is this secure. We're talking about should we provide a stronger guidance on sort of classical communication security challenges here.
Right.
Nancy Kamwinjit. So I was going to make the comment, and I guess I will, that just to say by providing TLS, their security, I don't think that's sufficient. I do agree with Hannes that we need to provide the right guidance. Regardless of whether we choose TLS or not, there has to be enough guidance for picking TLS as the example, the modes and the must to implement to ensure that security is afforded in the solutions.
Gabriel Montenegro. So I think this draft is about a transport issue. So I think it's perfectly in scope to talk about a minimal advice for transport security, which is, I think, is what has been proposed, you know, a default TLS on. That's definitely in scope. Now, it seemed obvious to me, but maybe you can add text saying, by the way, you're free to add more security. This is like the minimum, period.
Right.
That's it. You're not saying this is the solution. There's no such thing as a solution for security. We know that. Unfortunately, that's true. So, but this is like just the minimum. If you could add maybe editorially, the minimum thing required by default is this. Maybe that satisfies everybody. Maybe it's an editorial issue.
Darshak Thakur, Cable Labs. So I agree with the spirit of, you know, enabling security or mandating security, but I just wanted to point out that by saying TLS, you know, having TLS by default, there might be, as I think someone said earlier, is like it doesn't necessarily mean that it's secure. We actually have some implementations, or we've seen open source implementations where the default TLS cipher suite they use is an anonymous ECDH exchange. Now that might actually result in a false sense of security, and people may not even do application layer security because they think that we already have a secure channel. So I guess I think we should give a guidance and maybe even propose, kind of make it stronger. But I think if we want to make it stronger, we should make it stronger, maybe even more than that.
Hannes, so I don't think, so we have references to the TLS profile document
Yes.
in there.
Yes, we do.
And that elaborates on many of those aspects already. Of course, it doesn't talk about some design choices in OCF about the use of anonymous cipher suites. So I don't think that this document should talk about this either. I think other organizations then have to fix their problems themselves, and it's not our responsibility then.
Well, it might be a good idea for, as people are reviewing the document, to take a closer look at that section and just let's make sure we get the editorial language correct here, so we're giving the right guidance and definitely not misleading anyone about the level of security they're experiencing.
Ludwig Seitz. One thing that bothers me here is that the IAB statement says prefer encryption to clear text. And what we are saying is encryption equals TLS, which is not true. We're excluding object security if we say TLS is mandatory.
So the IB document, honest, the IB document was written not just for the entertainment of this working group. It has a much broader scope, and for some applications, there is no, and there's a completely different security requirement. So it talks about the high level story. The question in this context is, if unless we want to leave the security question totally open, we have to provide some guidance and say, like, what is useful to implement. And what I hear is that some people are working on object security, and their expectation is that there would be no lower layer security at the TLS, at the transport level. And so they would just use the application layer security mechanisms. And that's why they opt for not even, maybe not even have mandatory to implement, or at least not have it turned on by default. And so, and the challenge with that is, in order to see whether that's a viable story, we would have to see the application layer security story around this, which unfortunately haven't. And so it makes it a little bit strange, because some of us are using this specific document in deployments, and we actually use it with TLS as default, as Zach was mentioning, and also you guys do as well. And so we can think about whether we want to focus on what we actually do now, or what could potentially be a viable option. And then maybe the story also for the application layer security is that you have to use TLS all the way to the proxy, and then on the application layer provide some additional security to wherever it goes.
Yeah, Zach Shelby. So again, back to RFC 7252, we already had this discussion. We chose DTLS as our default security mechanism. It's mandatory to implement. Just to remind all of us that this document is meant to extend COAP for TCP support and WebSockets, and we should be compatible with what's implemented for UDP. I am not going to put two separate different implementations of security in a COAP implementation. COAP over UDP over DTLS and COAP over TLS over TCP needs to work in a very similar way. And this achieves that. So I don't think there's any reason to go change direction for what we do. We already have this in 7252. We should do similar thing here. And we should comply with what the IAB is asking for, which I think is really good step forward. So I'd say just do it and move on. I don't think we should open up the debate to something else.
Okay, Dave Taylor again. I just wanted to add something to Hannes's point about the IAB statement. I think, Hannes, you were on the IAB in 2014, right? This was still, so I think Hannes's name was on this one too. This is still within his term. So yes, he's right that this right here is a general principle. It doesn't say which protocol or which mechanism. And indeed, there's actually encryption at many different layers that protect different things, right? So if you have it up inside the application, then you might just be protecting the payload of a particular object, but not be protecting maybe the URLs of the objects that you're trying to get. And that may be privacy sensitive information, right? If you do it at the TLS layer, you might be protecting that, but maybe not the IP address that you're talking to, right? If you're using something like IPsec, you might be protecting, or even lower, you might be for IPsec tunnels or something, you might even be protecting that and so on. And so this is just a general principle that doesn't say which protocol you're supposed to use or what you're supposed to protect. It's just a general principle that says anything that might be privacy sensitive or confidentiality sensitive is something that you should find ways to encrypt. And so this can be applied at multiple different layers, and then it just becomes an efficiency issue that says, how many different layers do you want to re-encrypt stuff at, and so on. So this is to generate that discussion, not to provide the answer to that discussion. Right?
Hi, Bill Silverajan from Tampere. I agree that security should be on by default, and we should have a minimum, at the very minimum, something that says TLS should be supported for a very simple reason. Most of the deployments, IoT deployments, we are envisioning, considering constrained nodes and sensors, they're supposed to be in operation for a very long time, decades maybe. And we know that it is very difficult to get software updates into these when they're already in the wild. So to give a counterexample, if we actually just depend on application level security without saying anything about security at the transport level, then you're more than likely to get implementations and deployments out there that will ignore this possibility that there should be TLS supported there. So I think that's a good idea to actually have TLS as a default.
Juan Perez, Microsoft. I'd love to kind of present a question as well. It seems to me that where we see the question of whether a device should support TLS or transport security, it's usually at constrained, really constrained devices and at the edge. So for us in Azure, for example, we require TLS in the cloud, which makes a lot of sense in the cloud, but of course, it depends how constrained the devices get, whether they can support based on RAM requirements and things like that. So we see that at the edge with gateway devices supporting even more constrained devices, it's a question that's asked and it's usually driven by cost. So just a second Zach's comment about taking a position here and really leading. I think it's something we should consider. And if we leave it open, of course, I think by default having support this by default position, and of course, in some cases it might be chosen to not support it based on other network situations and setups. But I think it's something we can take a position on, and I'd love to hear everybody else if they have comments on that. Thanks.
Yeah, Carsten Moment again. I think people who are really cost sensitive will consider compliance to this document to be as expendable as other things. So it doesn't really make a big difference what we say here. I think what we say here should be sensible from a technical point of view in the direction we want to take this technology taking. Requiring too little security is wrong. Requiring the wrong security also is wrong, because it means people will stop doing the right security. So it's not always the right thing to write a document and say exactly what kind of security should be done. But I think it's a good idea to provide a default security, as we did with 7252, and use one that we think is flexible enough to solve a number of problems. So for 7252, we chose raw public key security and became quite specific about that. We probably don't have to be as specific here, because we can just point to 7252 and point out that we have this raw public key functionality in 7252. Yeah, I don't have a problem with saying it's mandatory to implement to have TLS.
Zach Shelby, just about the constrained nodes. What we see happening in the silicon industry right now is that the cost of 32-bit microcontrollers has gone to the point where they're just as inexpensive, even more so than 16 and 8-bit, just because of the pure volumes that we see out there. At the same time, we're seeing crypto acceleration. Thanks to standards like 7252, we now very clearly know what cipher suites are out there. So we're seeing all of our silicon vendors put the right kinds of crypto acceleration into these devices. And the end result is that it really doesn't cost any extra to add TLS. Flash and RAM sizes are increasing. Software complexity is already way up there. It's really a non-issue. 2017, no longer an issue. You might have some legacy devices that you might have problems, but for anything that's new, I don't see this being a big problem. So I don't think we should worry too much about that, and just recommend the right thing to do. I think what I'm hearing is that we're mostly in agreement with what you want to do going forward here.
Okay, then I will move on. One of the new features in signaling is the ability to have capability in settings messages. And one of the things that Karsten noted was that many of these messages are generally useful at initial connection time. So basically, these are messages that impact how a sender and receiver are communicating with each other in terms of the characteristics of the connection. So things like the maximum message size is now supported. An indication of whether there's support for blockwise transfers and BERT is indicated. And so there's a strawman proposal to do something similar to HTTP2 settings, where the first thing that happens upon connection is this exchange of capabilities. So they must be sent by both endpoints at the start, can be sent or may be sent any other times. And if you don't have any settings that you need to exchange because you're using what we're calling the base values, then you can basically send an empty set of settings. Seems pretty straightforward. Any thoughts, concerns about this? Adding this to the draft?
So requiring that both sides send something is probably the obvious part. One question that I think we haven't completely answered yet is who might be waiting on whom? For instance, there's a little bit of tendency not to send information from a server immediately, but to wait for things to come in from a client. So it might be that the server waits for the client capability message to come in. But if the client waits for the server to send the server capability message before sending it, then we have a deadline.
No, I think it would be client. Client would send first, and possibly could send additional messages before it receives the server's capabilities.
Okay, so we would kind of allow the server to wait for that, but we would not allow the client to wait for the servers.
That's one option.
Okay, is that the right option? Is that the one we are choosing?
But that's, no, there's a proposal out here. I want to discuss it.
Yeah.
I want to get people's opinions.
Right, that's why I'm asking. Do we have any other ideas for this should be done?
Gabriel Montenegro, responding to the strawman of doing it like HTTP2 settings. If you're going to do that, one good thing to do would be to make sure, and I haven't gone through a draft, but do you have defaults for every one of these potential things? Because having defaults would be great. That means you can allow sending stuff. For example, if you don't send it.
I think we have base, what we call, we don't use the word default.
Baseline, but it's
we call it base because default has a meaning in co-op options, which is if you don't send it, it's
basically
assumed.
the value you assume if you don't hear.
Yeah, so so it's like a default.
Yeah, okay. So as long as that's there, that's very useful. The other thing that would be very useful that's not in HTTP2 is there's settings and settings act. So I don't know if we're going to do that, if it's going to be that complex.
I didn't really
we didn't have them initially.
I didn't see the need for acts.
Okay.
If you do, for these settings.
If you do, then you want to piggyback, which is something we missed in HTTP2. You want to piggyback sending your settings with the setting act instead of making it separate.
Right. These particular settings didn't seem to require an acknowledgement. The small set that we have.
Probably simple, like we started in HTTP2. Okay.
Do you have an example for something like that? Which would need an act?
Which ones need an act? I think table change.
The table changes, yeah, in HTTP2.
Is there another one?
I think that was basically it.
That was the one that caused the act, addition of an act. This was for compression table, so you guys may not have.
Probably pretty much a modeling error because if every site just says what it is going to provide or to do, then you never need an act. But the other side may say, yes, I will do that, which you can model as an act, but it's usually more appropriate to model this as, yes, I will do this.
It was a very long discussion. We can take it offline.
Yeah. So negotiation is something that I think the people who finally made up the IETF learned when doing Telnet. So look at Telnet to learn how negotiation can be done.
Well, my intent for this was I'd be happy to write up a pull request for further review that would go into much more detail. I don't know how many people are familiar with HTTP2 settings exchange, but it'd be similar to that without the acknowledgements. Client sends first as part of its connection. The one open question is in HTTP2, because they want the faster transmission. The client can start sending data immediately to the server, but then it needs to respect the settings that it gets back later, like for flow control, for example. We have the one here might be the maximum message size, right? Could be violated early on by a client if it hadn't received the servers.
I don't think we should do that. I think each side should work based on the situation, based on the information that already has. So if you don't know that the other side has a larger memory,
So just use the base value.
Use the base value.
Hi, Bill again. So I understand correctly, the CSM allows kind of a very minimal framework for extending the mechanisms with new options. So are we establishing a kind of sub-registry for these options, or is it an open?
Yeah, I have to refresh my memory, but yeah, I believe there's a sub-registry for these options, similar to the options in the original co-op RC.
Okay.
Oh, this is an interesting one. So this is the intersection of signaling and WebSockets kind of being mashed together. So WebSockets have a ping pong, so which can be used as a keep alive or to make sure you have a responsive endpoint. And so when you send a ping, the other endpoint must send a pong with the requirement of as soon as possible. In the signaling draft, Karsten also added ping pong. And in its basic case, it's very similar to the WebSocket ping pong. You can send a ping and get a pong back. But there's another interesting artifact with a custody option. So you can get a pong back. You can do a ping without a custody option. You get a pong back that has a custody option indicating that it's processed all of your requests basically up to that ping. Or you can explicitly request in your ping, I want to get a pong, I want to get a custody option back with the pong so that you have processed, everything in the queue. So somewhat different behavior. Also, we have the ability to use empty messages for basic keep alives. So if you're doing co-op over WebSockets, we definitely need to provide some guidance here about which ping pong you should be using, assuming that you have control over both. And in some cases, maybe your WebSocket, maybe you don't have direct control over how often it's doing pings. My thought is because the co-op ping pong signaling is a superset, that we should prefer that over WebSocket connections and provide guidance not to use WebSocket pings. But I haven't thought this through in detail.
Matthias Kovac. So my first idea is these WebSockets ping pong is kind of similar to the TCP keep alives, with the difference that the problem was we don't have the control over the TCP keep alives. So obviously we might have more control over the WebSocket ping pong, but it also depends on the implementation. So if we have guidance, I would make it as easy and kind of common as possible. So give the guidance to use the co-op ping pong signaling. Also because there might be some extensions in the future with these options, so this mechanism that we have. So yeah, guide to use that, and then it makes it even similar over the different TCP, TLS, or WebSockets. So I mean, the general goal should be that we treat all these different stream transports similarly.
Okay. We always have to have a bike shed, right? So we've discussed the hard issues. So I brought one bike shed. There's a question about where do you put the S, basically, in the URI schemes. Do you do it so a WebSocket developer can read this and say it's CoAP over secure WebSockets, obviously, is the scheme? Or are you consistent with the CoAP secure schemes, which are all CoAP S plus some transport? What flavor ice cream would you like?
We can just poll. I mean, ask who likes CoAP S and who likes WSS.
We could poll or flip a coin.
Hello, Bill. Perhaps Klaus could explain better. We wrote the CoAP over WebSockets draft to reflect the URIs that were already existing for WebSockets. So they used WS for plain WebSocket connections and WSS for TLS-based WebSocket connections. And it seemed natural to adopt that. Our work with alternative transports has raised this issue time and again, whether we should actually have any kind of computation over the URI scheme. And I know that the apps area people tried to, there was a discussion then that about URI prefix registrations, which was not eventually adopted. So we should treat the entire URI scheme as opaque. So in my opinion, I think CoAP plus WSS is very intuitive. You see it and you understand what it means. But I also understand that the S here refers to something else than just TLS or DTLS. And if you want to put an S, I think that just be consistent. Let's put CoAP S plus WS for the secure WebSockets, or use CoAP plus TCPS for the secure TCP. But it doesn't really make a difference. In the end, it's just.
That's why it's a bike shed.
Yeah, exactly. So.
Yeah, I think, Customer, I think we have complete agreement that both forms are absolutely technically equivalent. So the question really is, does it make a non-technical difference? And so who is the audience who, beside the code that puzzles this stuff, actually interprets this? And the audience is the developers. And I think the developers would benefit from having a clear signal that a particular scheme is security oriented, and having that in the CoAP S part of the scheme name might help. So that's my little assumption here. Of course, the developer that exactly knows what WSS is might also benefit from that. But the developer that doesn't know that might benefit more from using CoAP S plus WS. But it's really a bike.
Bill, so should we adopt the CoAP S plus WS or CoAP S plus TCP? I think it would be wise in the document to mention that we are not actually performing any computation. So you should not be parsing the URI scheme as a substring to get the security part in. So that's the only thing I would like to say, and especially if we have not considered the third scenario in the future, where we might actually have a transport that is secure by default, which doesn't necessarily have any non-secure element. And are we going to just put CoAP S plus that transport, or is it just CoAP plus that transport? So I don't think it makes a big difference in this case, just as long as we clarify
that. Dave Taylor. I agree with the statement that schemes should be treated as opaque and it really shouldn't matter. But to Carson's point about if the goal is to reduce confusion among developers and people that look at the scheme and try to infer something from it, that person is a human, not a piece of code, then I think that there's a potential difference in meaning between these two that someone could interpret. Right? The CoAP plus WSS can be interpreted as CoAP over a secure WebSocket transport, and CoAP S plus WS could be interpreted as secured CoAP over a transport of unsecured WebSockets.
Yes, that
One
was
of those
exactly
two-
my comment on the issue.
Right. And so I believe the correct technical inference is the first one, right, which is WS is inside the TLS session, not outside the TLS session. And so if you want to reduce confusion, you'd pick the top one if my assumption is correct. But it's not a big deal either way. But if it was me, I'd pick the top one for that reason.
Thank you. So show of hands. Who goes with the top one? Okay, and who goes with the CoAPs, bottom one? And a lot of people don't care. Seems evenly matched, and that's how we know it's a bike shed. Okay.
I think that's it. Yeah, thank you. Okay, so thank you, Brian. Just to give a little bit more context here, we had this CoAP over TCP draft for a long time, and always said, oh, at some point we have to do the merge with the WebSockets stuff and so on. And we just never got around to doing that. And we're really lucky that Brian came around and did this for us. So that has been a significant push forward. And I think we can thank Brian for putting in the considerable energy that was needed to make this happen. So thank you, Brian. Okay, so Bill, do you want to talk about your part?
Well, it seems that something happened to the title slide. For the people in the back, this is our, not mine, but our draft. It's on protocol negotiation. I co-wrote this draft with Mert from Edison. So this draft has been a product that was actually it was taken because we were doing some work on thinking about CoAP over alternative transports and how we express the CoAP resources over different kinds of transports, and all kinds of requirements came up and all kinds of troubles came up about that kind of work. So the alternative transport draft focuses more or less on expressing the URI, and then we substrated all the use cases and produced a draft about how useful it will be if a client can understand that a server has different kinds of transports and how do you find these transports. Okay, so I only have a 10-minute slot, so I'm not going to be presenting everything, and the assumption is that you have read the draft. So the changes from the previous version has been that we took a good long look at the previous version, and then we decided to clarify a lot of examples. So we restructured so that we can in future edit it a little bit easily. And then a couple of things were moved into this draft from the alternate transports. One of them was a node classification table that classified CoAP servers, well, CoAP nodes endpoints, depending on the number of transports they actually have. And then we introduced a new attribute for expressing the information that the server can respond to the client about which transport is active by also saying that my transport will be active for this many seconds or not. So these are the biggest changes that took place. But I only have two more, well, actually 3 more slides. But for the forthcoming change, one very significant re-edit that we're going to do is to adopt the usage of URI templates to express different kinds of operations to discover multiple transports on a server. This makes it more consistent with the resource directory and the pub sub way of discovering the the function set. And previously, it was a very simple way in which we just defined an attribute type called TT that you used on the core. And but for now, we're going to go with the same way that's been being done in PubSub and also in resource directory by retrieving a web link. And then comes the next two things, which we wanted to just get some guidance from the working group. Firstly, the draft makes no assumptions about client-side transports. So the assumption is that you negotiate or you discover the different kinds of transports available from a server just on your current connection and retrieve what's available. That was not a bad idea, but it had some limitations. For example, we overloaded a situation whereby a sleeping node that could be woken up by SMS could actually receive a get operation over SMS, and then that is used to trigger waking up the radio interface for an IP-based communication. So there was a bit of an overload just from get operation. And we thought that we should decouple that operation away from just a simple resource retrieval. So we thought what could be the best way to do that, and we came upon the idea of using a new co-op option. So if you just retrieve what's available from the server, then, for example, over an SMS connection, in example one, if a UDP transport is requested, the server can say it's not found because that's not enabled. But if you pass this option, then the server can actually consider whether there is a need to activate the UDP connection or not. So that's one example, and the other example could also be if a client is already performing some operation and it wants to extend the active lifetime. So that's actually a server policy. So all these mechanisms are optional. There's nothing that has been specified as mandatory. So I'll be happy to hear if you have any alternatives to the above approach. And then the last slide that I have was based on thinking about how much context do you want to transfer if a client and a server decide to move from one transport to the other. We're really not in favor of pursuing this area of activity. So to give an example, if you already have a TCP session open and you actually have, let's say, a firmware update in progress, and then the client decides, okay, I'm going to, for whatever reason, switch to UDP, do you stop that firmware update or not? So we are inclined not to handle those things. Instead, just operations that are existing on one transport, for example, an observed relationship, do not get transferred over to another one. They continue as they should be, and then whatever you are doing with the new transport is its own. And then we are looking for reviewers for our drafts. So that's all I have.
So who has read a recent version of this document? Who would be willing to review a version of this document? 1, 2, 3 people, 4. So I'm seeing Christian, Ari, Matthias, Zach, Michael. Thank you.
So Zach Shelby, are you looking for a couple comments now?
Yeah.
If you don't mind?
Yeah,
okay.
Yeah, definitely.
So I think conceptually this might need a little bit more work. My feeling there's a couple things broken. Why are we trying to do this kind of on a peer-to-peer basis? So it almost looks like you're assuming that I'm going to do a direct lookup to the endpoint on well-known core, and I'm going to somehow have this TT parameter show up in every resource. Are we going to assume that every resource we have to mark whether it supports UDP or SMS? Shouldn't this be?
Yeah, it's a per server. It's not per resource.
Well,
It's per server.
But then you can't do it the way you're doing it now. So when you're doing it now, you're kind of overloading, you're requesting this, you get the list of links back, and you just have this showing up in the first link. Well, that means that parameter only applies to the first link. Yeah. Well, you kind of can.
Yes.
So you have to remember that there's a default target in RFC 6690. It's default. So if you don't have a target path, then it kind of does what you're trying to do. So maybe that works for this. But I think where this is more useful is in RD. Because if I want to go look up what transport somebody supports, I'm going to go look at the RD and see, oh, do they support UDP? So I think where you really need this TT parameter is as an RD registration parameter. Register it there so we can just look it up from the endpoint. The other thing that's broken here is that the way you're using the alternative relation type, so the alternative transport as a relation type, you need an anchor for that. So it's a triple, right? And right now, the way you have it is that the target is by default the host. Then you have the rest of the path is what's in that URL.
You should actually have a look at the examples. So
I did. You don't have an anchor.
There is an alternate relation, alternate location relation.
Yes, but in order for that relation to mean something, because you got to remember that as you request this, those links are independent. You get a list of links out of this, and you're assuming almost like you ask it, you get one link, and then a list of alternative transports for that resource. But that's not the case. If you want to do that, you need to include an anchor that points at the resource that it's an alternative for.
That's one of the reasons why we are using URI templates. So with the templates, we're actually producing an entry point for the protocol negotiation as well.
Okay, we have to look at how that works.
Yeah.
But I think what I'm saying here is that there's maybe a couple things we need to look at and look at 6690 a little bit more carefully.
Yeah.
So this applies. I mean, the idea is okay, but I think it needs a little bit more work.
Okay.
Thanks.
Matthias Kovac, this is also some feedback. So I quickly had a look at the draft. I didn't see the recent one or didn't read it. So I have a feeling that there's quite a disconnect to the usual web linking kind of discovery we are doing. But still you're kind of forcing it into the well-known core location that has, as Zach already mentioned, kind of a specific meaning. So you have a list of links basically, and you try to annotate it in the way that gives your functionality. So you try to do something different from the usual web linking kind of discovery we usually did in core. And then you had this slide here about the session that kind of really got me confused how this works out with the whole constrained RESTful environments. And
no, it actually does, and we were thinking if there was any use case for that. So it wasn't just an idea that somebody finds that useful, but we are really not.
But it opens like a huge can of worms that we don't want to have in this design in the first place. So
that's exactly right. Yeah.
It almost seems to me we should continue this discussion in 2 hours in the research group. It may not be easy to find a solution that really fits well here. But on the other hand, it seems it's a problem where we need an answer. So I think it's good to explore the space there a little bit, and we will need to continue this before we finally find something where we say that's it, that we can go with it.
Yeah, sure.
So thank you, Bill. So if you look at the agenda, there are 3 names there. There are 3. Zach has a comment.
Zach Shelby, can I bash the agenda still?
Yes.
Move those 2 around. I mean, that's a working group document we need to get done. I don't want to run out of time.
We're not out of time.
We always run out of time, so let's switch them and then.
Okay, let's do that. So just push your stage because you will need it for the next 90 seconds, and we go on to Resource Directory Michael.
So we've been busy on resource directory. Over the since the first of the year, we've gone through a couple of review cycles, and this is a list of what we've done. I don't know if we have to go through it item by item, but most of it has been improvements on what was already there and clarification and filling in some missing items of the functionality that's been defined. So clarifying some things, making sure everything works right. There was an implementation undertaken during this time, and a lot of good first-time user questions came out of that got addressed. And so we've been focusing on tying up the loose ends in this draft and not adding a lot of new features. There were a bunch of issues on the issue list. There's still pending issues, but most of them are done. So there was one, let's see, one link attribute format syntax I just missed. I did some other thing that was related to that, but I didn't do that one, and I'll get that one. There are two requests for essentially new features that we've decided we won't do, but there are some things in those requests that might be good for text clarifications or adding some things, but I think we decided we won't add any new features. I guess that's still, anyone could come up and say, no, we really have to do this, but pretty much the roadmap is to not add new features and keep it in the original scope for the most part. So the status is we've resolved
Mike, could we go back?
I say we resolved, okay. Oh,
Sorry.
a question, good, Rama.
Yeah, this Akbar.
One of these is yours.
Yeah, for the 406, I agree that part of the ticket had new features, but also part of it was clarification, especially for the security/privacy that.
And I just reviewed it and I agree with you. And that's kind of why I did that qualification. I think some of that in 406, as we resolve that, we may end up adding some text we will end up adding some text, I believe, to the draft. I think you raised some good points about what if there are, multiple different sort of domains on an RD, what is the permission thing. We don't have ACLs, so we have to have a different answer than that. But and then on the other one of the other issues was something that we should at least explain. Now, I think it's chaining of one RD to another, and I think we said you can always put a link to an RD in an RD, and I don't think we identified anything more that you would need to do beyond that. So
yeah, okay. Yeah, that's good. We could carry it out on the list. Yes, thanks.
Okay, thank you. So the status is we've resolved. I say resolved. We haven't cleared them. We have to still figure out how to make them go away. But we've resolved the issues in the issue tracker, all but the one we need to put in. And we'll as we finish those up, we'll follow up with the submitters and make sure that that we're aligned. Incorporated comments and suggestions really from a lot of comments and suggestions over the last few months. We've been through 2 rounds of reviews, and as I said, we're not adding any more features or additions because we're preparing to go into working group last call with this draft.
So this is the milestone we have put up here. We plan to submit this to the ISG in September. So that means we really have to have our working group last call soon. Who has read a recent version of this document? Who would be willing to review this document in the course of the working group last call? Okay, we have 5 arms. Matthias, Hannes, Klaus, Dashak, and I don't know your name? Sebastian, thank you. Sounds good. I didn't see Bill. Okay. Oh, Bill, you are behind Brian. I didn't see you. Sorry. Okay, good. So amazingly, we are not exactly running out of time. I put in this, it's not really a 10-minute thing because I didn't ask people to send in slides. But there are 3 drafts out there that also talk about other transports. And I would like to ask the authors of these three drafts to do 30-second elevator pitches for those drafts, so people know why they are out there. And I was going to do this in alphabetical order, and Carlos is the first one on the list. So can you just go to the microphone and do a 30-second pitch?
Hello. Yes, we submitted the version 00 for a draft which is entitled TCP over constrained node networks. The main goal of this document is to describe lightweight, measures for lightweight and suitable operations of TCP for constrained node networks. The main motivation is that we have this specification of co-op over TCP in progress, but there are other application layer protocols which are also being considered for IoT, such as IETF in several variants, and even other protocols such as MQTT.
The only one. Thank you. Christian?
Okay, Christian Groves. I submitted a draft on the usage of co-op over WebRTC data channel, which is essentially a SCTP DTLS over ICE, so that's UDP or TCP transport. The idea is to enable peer-to-peer communication between two WebRTC endpoints utilizing co-op, and that basically means that you can multiplex co-op with other real-time transports like RTP over the same DTLS connection. So you have the advantages of using the one DTLS connection. So a lot of the work's already done already in WebRTC, so it's a pretty straightforward transfer. It seems to work fairly well with what's already been defined for the TLS TCP work items there. So it's a similar structure, and we can use the same packet format, what have you. Thank you.
So who in this room is actually interested in this kind of area of application, co-op over WebRTC data channels? So if you are interested in this, talk to Christian about that. It's certainly something that hasn't received as much attention yet, because WebRTC also is new, and there are enough other problems to be solved in the WebRTC space. But it's very well conceivable that you want to do things like camera control or whatever over co-op in a WebRTC data channel. Okay, the third draft that is in this possibly excuse me, in this possibly related work is by Jin Cao. Is he down? Is he there?
Jin Cao. So basically, it's about a measurement study of the co-op from an Android phone to some place in the cloud over GPRS and Wi-Fi. There's some data in the draft. So if you are interested, please read the draft. That's what the draft is about.
Thank you. Okay, amazingly, we have 17 minutes left. The only item I can pull forward from Thursday, because I already have the slides for that, is this one. So Carlos, can you do this one? So prepare mentally to the other things that will be there on Thursday, and read the drafts.
Okay, I'm going to present the draft entitled Co-op Simple Congestion Control Advanced, COCO. This is the latest revision of the draft, 04. I'm one of the authors, and the co-authors are Carsten Bormann, August Petzler, and Ilker Demirkol. In this presentation, we're going to cover a few performance results, completing some results which were already started in Yokohama, were presented. Then I'll focus on which are the updates in 04. Then we have a few preliminary results about the last mechanism which had been added to the draft, which is the mechanism for aggregate congestion control. And we also would like to ask whether the document is ready for working group adoption. So in Yokohama, we had presented some initial results on the performance of COCO for the transmission of non-messages. In that case, we had a proxy which was sending emulated sensor updates to a number of cloud subscribers. This was through some emulated GPRS link. The purpose here was to compare the performance of Default Co-op, Observe, and COCO. So in the results on the left, what we could see is that, well, actually there were several rounds of notification updates, and COCO was able to achieve high PDR. Actually, Observe was performing quite well. However, for the offered loads, for the highest offer loads, COCO was still achieving a greater performance than Observe. Default Co-op, because it doesn't have any rate limitation to the non-messages it sends by default, then it actually leads to buffer overflows and a lot of losses. And then we have also extended the work by performing actual experiments in a 16-node 15.4 multi-hop testbed, which is called the IoT lab, located in Grenoble. We are also comparing the performance of these three variants, Default Co-op, Observe, and COCO, while several nodes are sending non-messages. So in this case, we can see that Observe is actually failing to achieve good performance if we compare it with that of Default Co-op and COCO. That's because Observe has a very static rule, which is that messages cannot be sent at a rate greater than one message every 3 seconds. So overall, COCO is adaptive, so it's able to provide good performance in a wide range of conditions. So about the updates in the latest revision of the draft, the updates are mostly about the aggregate congestion control. So we had already we had added the initial version of the aggregate congestion control mechanism in version 0.3. However, in this latest update, what we've done is we have modified the parameter called lambda, which in the previous version was a constant value of 4, to a new value which is actually dependent on the number of intended destinations, because the idea is that static lambda is of course not offering a good performance in a wide range of scenarios, and this is the approach that we are proposing here to be able to make this lambda dependent on the number of destination endpoints. So we added some example to further illustrate the effect of the above change. And in addition, we moved the aggregate congestion control mechanism to an appendix, as we understand that probably that's not a mechanism which is always interesting. Most probably this is interesting on the cloud side. And by the way, a question we have for ourselves and also for the working group is whether this appendix, the aggregate congestion control, whether it should be part of a separate document or not. We have, by the way, started working on the performance of ACC. So far, what we have done is we are using an emulated GPRS scenario with an unconstrained device sending messages to a variable number of destinations. And what we are doing here is we want to see how which is the performance when we send messages to a number of parallel destinations. And we are comparing this with Default Co-op and also with COCO without ACC. So this is just preliminary results. We're actually somewhat in the process of validating what we are obtaining. However, it seems like ACC provides an additional limitation to the rate by which messages are sent, So this, in principle, should be able to obtain similar or even greater PDR than without this mechanism at the expense of possibly a great application delay. Nevertheless, this is something which is going on, so we plan to do more research about this mechanism. And as I said before, actually we are considering whether this should be part of the COCO document or whether there should be a special separate document for this. So now that actually there has been a significant body of research done on the performance of COCO, we can say that COCO is stable and well-performing. We understand that, not for ACC, but for core mechanism of this algorithm, maturity has been reached. We have performed, we and other researchers have performed several evaluation studies by simulation, emulation, and through actual experiments. Several link layers and network setups have been considered, such as 15.4 multi-hop networks, GPRS, UMTS, Wi-Fi. And we have evaluated the performance with cons, nons, and different traffic patterns. And several alternatives to this mechanism have been considered, such as a strong-only version of COCO, the peak hopper algorithm, which is a state-of-art TCP RTO algorithm, the Linux TCP RTO algorithm. Then the work about COCO has been presented several times in the IETF. We have here the whole list. For instance, in the co-working group, this has been presented in IETF 87, 89, 90, 91, 94, and 96. And in addition, we presented COCO in the ICCRG in IETF 92. So as I was mentioning before, there is already quite a number of documents of papers which report evaluation results on COCO and other mechanisms. So, for instance, as Zhensao was mentioning right now, there is some internet draft which has been recently submitted, which performs a co-op latency evaluation considering COCO. Then there have been several conference or workshop papers, such as the ones shown on the slide. And there is also other papers which have been published by mostly the authors of the algorithm, such as the ones here. And also there have been several journal or magazine papers, such as the ones shown here. And by the way, I recommend the second reference shown on this slide as possibly the most major tutorial style and most complete reference on this algorithm. And by the way, a significant part of Dr. August Betzler's PhD thesis has focused on COCO. And it's also important to mention that we have running code. So we have an implementation of COCO for Californium. Here there is the link. Then there's also an implementation which is available for Erbium. The link is not included here, but we can provide it on the list if necessary. And also libcoop has been ported to Android with COCO, which is the actually the work which was done in this internet draft by Zhensao. So that was all. So considering that we understand that we have completed, let's say, the possible gaps that there were in the document and the level of maturity that we understand we have achieved, we would like to ask whether the working group considers that the document is ready for working group adoption.
This is Hannes. I was wondering about one aspect. So you mentioned in the other draft that was mentioned earlier about the co-op comparison, there's also a comparison on the congestion control, but there's also a discussion about the TCP co-op, the comparison between co-op over TCP versus co-op over UDP, and I was wondering whether the document also could say a little bit about that.
So which is that document?
That's the comparison document that was also mentioned.
The document that Zhensao just talked about. So just to give a little bit more context, Carlos had said this has been presented about 10 times here, so it may be familiar to many people, but it's also been 4 years, so you may have forgotten it. So in August 2012, this idea came up. We were essentially done with the COIP standard at that point in time. COIP has a very conservative approach to retransmissions because we wanted to make sure we never overload the network. And the question was, can we build something that's slightly less conservative, still probably way more conservative than TCP, but in many situations actually quite reasonably close to TCP if you're not doing bulk transfer, but if you're really just transferring single measurements. Now, congestion control is hard, and that's why it's important to do research. And I think what Carlos has been trying to say is that research has now been done. There is an additional thing, this aggregate congestion control, which maybe isn't completely in the state where the research has been done. So my advice to the other authors of this document would be, it doesn't really hurt to have another document with that. So we can always do this in a year or so when we do have the research. I would focus on the relatively simple point of having a congestion control solution for a node that doesn't want to be bound to 2 to 3 seconds of wait time for a retransmission. This is really the point of the whole thing, that as soon as you measure RTTs, you can react faster or also more appropriately based on congestion you actually may be experiencing to congestion and have better reaction times in the end. So my recommendation as a co-author, the chair is sitting in the front, I'm just standing here as a co-author, would be that we finally put a lid on the main part of the document, factor out the aggregate congestion control, maybe work another year on that or two, and get the research in place, and then look at that whether we want to do it or not.
Yeah, Zach Shelby. So agreeing with Carsten, I'd also say that I think we're ready for working group adoption with this. I mean, to be honest, I was a little bit skeptical 4 years ago of how workable this was, how accepted it would be in the IETF community. You know, we had Lars come and talk. Oh, Lars is here right now. You know, we had Lars come and talk to us about how kind of hard this problem is back then. But you guys have done a huge amount of work on this. Thanks for that. I do think there's some things that we still need to check, sanity checks, before we publish, but we've got time between, you know, accepting it as a working group document and doing the final work. So talk about that offline. But I think we should go ahead.
Thanks.
Yeah, Zhengchao. I also think that this document should go ahead because I found it useful. What we need to discuss during the process of this document is what kind of RFC it should be. Either it's experimental or information or something like that. I think that's still discussable, but generally I think for the question you list put on the slides, I will be very supportive.
Gabriel Montenegro. So I haven't followed this document that much. So I'm wondering how. So I noticed this is an applications area working group, which probably doesn't have the transport savvy that this particular document requires. I'm wondering how extensive has the transport area review been of this document? I know there's been a lot of publications, but within the IETF, how extensive has the discussion been there? The reason I ask is it should be discussed along with, you know, all the improvements that, for example, the 4LS BOF going on right now. That community should look at this. And the other reason why I was thinking about that is your document that you talked about on the microphone, you know, 15, 20 minutes ago about TCP optimizations, mentioned that COCOA could be one of the possibilities, even for TCP. So definitely that, at least for that reason, it should be talked in TCPM and the usual circles. So have those usual circles been discussing this?
So first of all, I understand that there was a special session about congestion control. I think it was IETF 84 in Vancouver, if I don't make a mistake here. There was a lot of transport area folks who came and gave ideas about how we should handle with this. And then shortly after, Carsten wrote the initial version of this draft. So I understand that the main ideas proposed in that special session were captured in Carsten's original version. And then mostly what we did after that was to fine-tune a little bit some of the parameters to make sure that the algorithm was really working well, let's say weighting in some appropriate amount the impact of several aspects or mechanisms on the algorithm. And then on the other hand, we also presented this document in the ICCRG, and we actually had a lot of feedback, for instance, from Richard Scheffenegger, who suggested that we might compare the performance of COCO with that of other state-of-art TCP/RTO algorithms. And that's actually what we did, and that's the core for the Communications Magazine paper that's going to be published.
The problem is that the complete answer to that question takes 20 minutes, and we have about zero. So first of all, this is adoption. This is not working group last call. Second, when we actually working group last call this, we will have to involve transport, ICCRG, the kitchen sink. So yes, this will be done. I think that's really important. This is congestion control. But to answer Jen's question, I don't think we need to go for experimental with this because it's no longer an experiment. I mean, the experiment is running out there with all the implementation that is going on. But we have a phase from the adoption to actually shipping this document where we can find final problems, and we will be using that phase. So
maybe before people are leaving, a quick show of hands. How many people have read the draft first? All right. How many are in favor of working group adoption? How many against? All right. Then it's working group adoption. Yeah, of course, I'll confirm on the list. Sorry.
yes. So see you on Thursday. So we're going to have lunch on Thursday? We're going to have lunch on Thursday?
Thank you. Yeah, thank you. I'll leave it here.